layer. Yes. So last time we did the physical layer. We did the physical layer. Is recording started? Okay. So today we're going to do layer 2 called the data link layer. So at this stage of the OSI, so remember your OSI, so quickly have a quick, you can check here. So we have a physical layer, then the data link layer. Where this one is going to? So today we're going to do the data link layer. So at this layer, we'll deal with what we call the switch. So as you know, a switch is a device that will be used to link all the pieces in one place. It's very important because if we didn't have a switch, how are we going to all get connected to the router to go to the internet? So if I open my packet tracer quick, a packet tracer here, and in this switch, I will see what is inside, and that's something very simple. Something very simple. So I'm waiting for the packet tracer to open, and the packet tracer is here. So at the switch, understand only MAC addresses or physical address. Then next time when you do the layer 3, the router understand only IP addresses. So we'll see how we switch will manage MAC addresses. So this is something I'm going to put my my PC, my router. I'm going to put my router here. There are some laptops. See, always, guys, if you want to go to internet, we have a way of design. We connect all of them to a switch. So next time, when Scalabrini confirms when we meet, I will bring some switches so that you can check also. So this is why we use this switch, is to interconnect end devices, the end user devices, laptops, PCs, servers, in one place. And from this switch, we use it to go to the internet. So when you work in a company, no one sees that. People will see only PCs. But in the background, we are all connected to a switch. And this switch is connected to a router. And this guy, router, will go to the internet. Okay. So I'll register you for a short course for Packet Tracer. Else, if you download and install your Packet Tracer, you just need to come help tutorials, and there are a lot of you see these small videos, short videos. You can watch them until part 5. You take your time to watch them, practice a bit. I'm repeating myself again. Cisco is about practicing, doing the same thing many times. The more time you do, more yeah. So this is our switch. So internet here, I put here router, I put here switch. PC1, PC2, PC3, PC4. Yeah, so this is something. So this switch is very, very important. So we have two types of switches. Job interview, I can ask you, we have two types of switches. We have what we call unmanaged, and we have what we call managed. Managed. What does it mean? It means if you have it unmanaged, it's like a toy. You plug, you bring all your pieces. I'm going to bring everything down here so that you can see nicely. So the unmanaged, there is no configuration we can do. It's like a toy. You connect. We are all connected, but there is no setup you can do. Like your cell phone. Your cell phone you can configure. You can change names, colors, what. We call it managed. You can set up. You can change. You can configure. We call it managed. But the unmanaged is like you have a cell phone. Nothing else. You receive calls. You receive SMSs. You cannot change anything. So nowadays, we use what we call a managed because we need to configure to set up stuff inside. So we have two types. In the two types, what else? There is something called also MAC address table. MAC address table, MAC address table. You see? So inside this switch, we have a table, like something, let me check like that, you see. Insert table, you see. Something like that. It will tell you, okay, port 1, MAC address of PC1. And let me use yeah, okay, it's fine. So you see, port 1, MAC address of PC1. If I copy, and port 2, so it will record on each port the PC that is connected to that port. It's what we call MAC address table. It's a table with a list of ports. Each port is the MAC address that record the MAC address of a PC that is connected. So on port 7, it's for PC7. Port 6, PC6. Port 5, PC5. Port 4, PC4. Port 3, PC3. Port 2, PC2. You see. So this is what we call a MAC address table. It's a record of MAC addresses per port of each devices that is connected to that port. That's all, nothing else. So that if PC1 want to communicate with PC7, so if PC1 want to communicate with PC7, the switch will know, PC7, I know the MAC address, it's on the port 7. and it's going to send the data on that port. That's all for MAC address table. So let's do a demo. Let's check in our, if I open the switch here and I go to CLI, command line interface, I press enter, enter. When I press enter, enter, I'm here. This is the user mode. I want to go to the privilege mode to view more stuff. Enable. I'm here. So now what to do? I tap show. Show. So first, if you're not too sure what to type, you just type question mark, and you have a lot of commands that you can use. So if I go down, I can see I can use the command show. So anytime you want to view something, you tap show. Now, space, you don't know what to type, question mark. And you can see I can use the command here, MAC address table. So show MAC address table. You're not sure, question mark. Okay, you can type all of this stuff, or you can, if you see CR, it means there is nothing. You have the option of not typing anything else. You just need to press enter. I press enter, enter, and you see MAC address table. You see, it's a kind of table I was doing here. But for now, you can see that it's empty. There is no traffic. Let me generate a small traffic. So here I'm going to add some stuff. Uh, okay, I'm going to make some traffic. Some traffic so that we'll see what will happen. Okay, so now if PC1 want to talk to PC7, now we go to command prompt. That terminal that we are using, so you use that terminal only if you're using a console cable. If you use a console cable, then you come to terminal. But if you want to check connectivity, if you want to dial numbers, you come to command prompt. And to dial, you tap ping and the remote PC IP 192.168. Okay, let me do that. I'm going to generate traffic. Okay, always we'll do a bit later when you do the router. But for now, I'm just going to generate some traffic, that's all. We'll explain all this later. Then I do the last one, 5. Okay, so now I'm going to go to the switch again and type show MAC address table. I press enter. Now we can see that it's populated. We see port 1, port 2, port 3, port 4. And on each port, it's the MAC address of the PC that is connected to that port. So this is the MAC address of PC1. This is the MAC address of PC2, you see. So that's all. This is what we call a MAC address table. So that if someone wants to go somewhere, the switch will know where to forward your frame. See, the switch will know where to forward your frame. It's like you have a security guard at let's say a building, and you want to say, okay, I want to go to, let's say, Department of Health, and say, okay, if you want to go to Department of Health, use this lift, go to first floor. So you see that security guard knows where to help you, where to send you to. It's the same thing for a switch. Each port has a MAC address, so that if you want to communicate with someone, he knows, he'll check in the table and forward your data. This is the second thing you should know about a switch MAC address table. Now, forwarding methods. How the switch will forward methods and will forward your data. Forwarding methods. We have two. Or how the switch will process your request. We have store and forward, and we have also cut through. You see, store and forward and cut through. So what I'm showing you my experience, what we use, what we do in companies when it comes to. So if you have a switch, you see here I have how many ports, how many PCs? 4 PCs connected to a switch. Any other port you're not using, you must shut them down. If not, it's like you have houses and you have open doors. You must close the doors. If you're not using somewhere, you must close the port. You must shut down. So I come to my switch. If there is a command, I need to type to view all the ports on my switch. What command is that? Is show IP, show IP interface brief. So if you want to view all the ports that a switch has, you tap this command, show IP interface brief. Someone is not muting his, yeah, not mute. Show IP interface brief. If you tap that command in the privilege mode, you'll see all the ports. If you port 10 until port 24, and we have other type of port again, you see. So if you're not using, you see here, you see up, it means these ports are connected to something. Anything else you're not using, you must shut them down. So we'll get some labs to do that. So you go to that interface and you tap shut down. Now, if a switch PC1 want to communicate with PC4, when the data, the frame will arrive at the switch will do that, will do what? Same thing like the security guard. Some of them will check your ID, and they'll use that device to check if you don't have a gun or knife. We'll check in the system if really you have an appointment. We'll maybe call the office to confirm if Gautier has an appointment, or Mire has an appointment, or Mwala has an appointment. You see, if everything is good, then the security guard will say, okay, you may proceed. You can go inside the building. So this way of checking everything before forwarding is called store and forward. Store and forward, I check everything, no mistake, no, then. So it takes time. There is a bit of delay. The other option to forward frames or to forward data by the switch is called cut through. This one is a bit quicker. So when you come, you say, okay, hi sir, I have meeting with Mr. Max. And say, okay, do you have an ID? Yes, this is my ID. Okay, it's fine, go. So it doesn't check if really Mr. Max is there, if really he has a meeting with that guy, if the appointment is valid, if what, you see. So cut through, I check only a few things and I'll let you in. It's quicker. These are the two ways a switch forward data. Remember, we are IT engineers. We are doctors, not medical doctors, but doctors of IT when it comes to networking. We need to know what's happening, what is wrong. We need more info so that if there is an issue, we know where to go and fix. So when you have a switch, we have two types of switches. Unmanaged, it's like a toy. We cannot do some settings or configurations. Then we have inside, you also have what we call managed switch. If you don't know, you can Google it. You can Google it, you can go to YouTube, you tap difference between managed and unmanaged switch. You must be curious in IT. With a lot of YouTube videos around Google, even AI today. I can go now here. I open here. I tap difference between managed and unmanaged switch. You see, it's even here. You press, you see. Then you'll get all your answers. You see, unmanaged switch are designed to just plug in and run like a toy with no settings to configure. You see, you even go to Cisco system. So be curious in IT. What I give you, I open your mind. I give you the foundation. I give you directions. What you should know the most. Now yourself, when you study, you do some research. You make your own notes for yourself. That's why even if we finish the training, the NETA card is still open for you for 6 extra months for you to go through it again or study, you see. What else you can know from the switch? The MAC address table. Recommend, if you want to view it, show MAC address table. Recommend to view that. Let me type it here. Show MAC address table. You tap that comment and you'll see yeah, per port, what is the MAC address of a PC that is connected to that port. It's very useful. Now, how the switch will forward data if PC1 want to communicate with PC4, when the switch will receive the request, it's going to check first thing first on the MAC address table to know where to forward the packet. But before forwarding, you have two ways of checking. You can check if everything is okay. There is no damage on your parcel. You see, for example, on your packet, there is no damage. You're going to check source MAC address, destination, what. If all good, is good forward. Else you can say, okay, you want to go to port PC4. Okay, I know where PC4 is. Just go straight. You see. So these three things are things you should know for a switch. I'm going to add more info for you. So the switch also, inside we have two technologies. Okay, this one you don't need to memorize. What is the most important is what I explained to you here. You should know also what we call the difference between full duplex and half duplex. But nowadays, full duplex. Nowadays, all the switches comes with full duplex. It means what? Full duplex, it's two-way. For example, on the road, you have a car going, a car coming, and we have two lanes. One going to the south, one going to the north. Full duplex, it means on this line between the PC and the switch, we can communicate at the same time, no collision. You see, what we call full duplex. Half duplex, PC, this PC, if this PC wants to communicate with the switch, this PC must listen to the media, to a cable. Is it free for me to go? So like you want to cross a road, you check first. If it is a car, you stop. You leave a car pass first, then you can. So we cannot communicate at the same time like full duplex. One first, the other one waits. Then when the line is free, then the other one can communicate. You see. So also in EtherCAD, there is explanation for that. The difference between full duplex and half duplex. But nowadays, we don't need to know that because everything is full duplex. We are training you. This course is to become network engineers. Good guys in IT will pay you a lot of money for that. So you must know the good the theory, so that the way they give you. Remember, when you go look for a job, you put your CV with all your certificate. Then we're going to test you to ask you some and to verify if really you did study. Ask you some few questions like that. And so if you go in your NetAcad, you'll see uh, we'll call logical link control. Okay, this layer, this section will prepare to receive data coming from upper layers. See, my email is here. I press send. It will go down to a router, to a switch. You see. So between the switch layer 3 and layer 2, this layer will welcome anything coming from the router, for example, for layer 3. And this one will prepare that packet to go to the physical layer. It's only theory, so you can yeah, you can read this one quick and we continue this too. Okay, so it's just to know, and that inside we have that, and yeah. So normally we are done for normally chapters 6 and 7. It's what you should know the most. So I'm going in your to check if there is more info to add for you. So we go step by step. Data link layer. Let's go in your NetAcad. So with data link layer, responsible for communication and device network and device card. Okay, so as we said, if you send a parcel, your envelope, for example, your email, you click send, your email is at the application layer. It needs to go down, you see. So anytime it reaches a layer, we'll put extra info to allow your message to go. For example, we're going to add this one, you see. For us, we don't see, we don't touch it, but we need to understand what's happening in the background. When someone press send, for your message to travel to go, it's like you go to the post office, you drop your envelope and you go home. Do you know what's happening? Do you know what is happening at the post office from your envelope to reach destination? No. But for us IT engineers, we should know what's happening at the post office. How do we process our stuff? So our envelope will get some stamps, source MAC address, destination MAC address, source IP, and destination IP. Layer 2, layer 3. That's why the MAC address is very important. So the switch will manage here with the MAC address table, and the router will deal with the IP address. We get time to repeat this one many times. And yeah, so when you have your data link, we have the LLC layer. This one will welcome anything coming from above, then pass it to the MAC address, and the MAC address will make a treatment to go to the network media, to the network cable or Wi-Fi. Yeah, that's all. You don't need to memorize that. Okay, these ones, data link standard. Okay, these companies, they decide how things will be. Yeah, your big companies in America, yeah, we decide. For example, to go to university, you must get matric. No matric, no university. We decide how things. Um, okay, physical topology. Sometimes we'll hear topology. It's the way it's designed. For example, what I have here is a physical topology. You can see it. You can move. We call it physical topology. Logical topology is what's happening inside you cannot see. When you send your data, you don't know, you cannot touch it. You cannot touch a MAC address. Anything is called logical topology. So physical topology shows physical connections and how devices are interconnected. Logical topology identifies virtual connection between them. Okay. You can make some notes. Okay, this one you can skip. We don't do that anymore. Point-to-point topology. I have my router, I connect directly to another router. We call it point-to-point. We don't do that anymore. The most used is a star topology, where all the pieces are interconnected to a switch. We switch to a router. When IT started in 1960s, we were using all of this, but nowadays we use only this. Well, all your devices are connected to a switch. We switch to a router. We call it star topology. Anything else are old. We don't use them anymore. I was explaining half duplex and full duplex. So you can read this one, very important. Okay. Now, if you have half duplex, we don't use it anymore. How can you drive on a road? It's only one way. People will get annoyed. You need two ways at the same time. One going to the north, one going to the south. So these technologies, one-way stuff, we don't use anymore. So in the old days, before I cross the road, I need to listen to check left, right, if there is no car coming. That technology to check and allow you to go or stop was called CSMA-CD. We cannot see it, we cannot touch it. It's a program inside the switch. So as a network engineer, it's good to have an idea, not to memorize, but to know that in the old days, this is how it was working. We had many halfways, one ways. Nowadays, we have two ways. So to manage the network cable, we call it CSMA-CD. To manage also the wireless, the Wi-Fi, it was CSMA-CA. It was old technologies. We don't use them anymore. to avoid collision accident. You see, you'll see legacy. We don't use them anymore. In fact, we should remove all these things because we don't use them anymore. Yeah, so the frame is the packet, the envelope we find at the layer 2. So inside that envelope, we see your data, your normal email, your message. Then we have other stuff each layer will add, like some stamps to go, allow you to move. You don't need to memorize. I'll show you something very simple. What we know, any packet to travel need a MAC address, layer
Sorry,
2.
Mr. Khan. Mr. Max.
Yes, question?
Is Eugene?
Then you did, yes.
Eugene. I would like to know the difference between frame and the trim.
Frame end.
You said frame.
Yeah, frame is the data. So check here. I'm going to show you again.
Mm.
When you have the OSI model, at the application layer, presentation, and session, the PDU, the name of the
Mm.
envelope we find there is called a data. When you leave
Mm.
all this and you go down, when you reach the transport layer, that envelope will be put in other bigger envelope from the transport. And the transport will say, okay, me, I'm going to use either UDP or TCP to allow you to go. So that big envelope is called a segment. When that big envelope arrives at the network layer, this layer will put that big envelope in another bigger envelope. We call it a packet. On that bigger envelope, we'll add source IP address, destination IP address. When that bigger envelope arrives at the data link, that bigger envelope will be put in a bigger envelope again, and we call it a frame. So the frame will add, the switch will manage that, and will be dealing with MAC addresses. So for us human beings, we don't see, we don't touch, but what's happening in the background is what we do. So a frame is a bigger envelope coming from the top. You see, your normal data is here, and other layers will add other stuff. So that big we find at the layer 2 is called a frame. That's all, nothing else.
And the trim
You see your normal data.
is the,
So what
is
is
the
the trim? What
trim.
is it? So what did you see trim?
No, I don't see the trim.
No, we say frame. We didn't say trim here. So your normal
Oh,
data
okay.
is here, and we're going to add other stuff. So it's only frame. Okay, so let's continue. And that's all for chapter 6. In chapter 7, it's the same thing also. For chapter 7 is about how the switch will process your stuff. We have two methods, cut through and store and forward. Okay. It's that frames. Okay, it's so the frame, it's a layer 2 of a data link. It will switch that is here. It will manage the MAC addresses. So we have LLC that will welcome anything coming from the network layer going down. When it's processed, it go to the MAC address, and the MAC address will send to a physical. For you to know that. But the LLC, MAC, okay, you have more explanation. And so the way of putting in bigger envelope is called encapsulation. We put in a bigger envelope, we call it encapsulate. Yeah, so here we have a lot of, so this is normally your frame, your big frame, your normal data coming from the top, and each layer will add other info. So at the frame, this is a big frame here, Inside, we have source MAC address. Where do you come from? Destination MAC address. Where do you want to go? Then we switch, we'll check here. Where do you come from? Ah, you come from PC1. Okay. Where do you want to go? I want to go to PC4. Ah, okay. I know. Go that way. Yes. So this is the envelope at the layer 2. We call it the frame. We have some rules here. The length should be between 64 and 1518 bytes. If it's less, you see here, if it's less than 64, we call it a errant collision frame. It means you're not complete, you lost something. Let's say a normal bus has, let's say, 100 seats. But if that bus arrives here and only has 20 seats, we can see that there is something wrong. I cannot welcome you. Maybe you got an accident, you lost other stuff, you see. So it must be, the length of that envelope of the frame should not be less than 64 bytes and not more than 15, 18 bytes. We call it baby giant. For now, you don't understand maybe why we do that, but I was working for Telcom for America. We call it AT&T in Johannesburg, and we need to help clients with internet. Sometimes it's too slow, sometimes we have to check all this stuff. So only here what you need to know, this is the size of that envelope at layer 2, not less than 64, not bigger than 1518. That's all. Why they give you all this info is for troubleshooting. In case one day there is a problem, where to go to fix. Okay. Job interview, if you're 20 candidates, you want to take the best of the best, we'll go deeper to ask even very small questions to see who is the best to be taken. So take your note, make your summary. If you see something important, make a note of it. Okay, MAC addresses. We did that last time. We'll do that again. So we still have time. We still have 5 more months. So unicast. You know unicast now. Audrey, you were asking me what is unicast. Unicast is a one-to-one communication. You see, PCH1 want to communicate with only one guy here. So one-to-one. It's called unicast. Social media, we say DM, direct message. It's called unicast, one-to-one.
All right, Mr. Max.
Okay.
Yeah, I saw it in last time when I was studying. I saw it also. Thank you.
Yeah, no problem. You're welcome. Broadcast, you know, I'm talking to all of you in the class. I'm broadcasting. So broadcast is one communication between one to many. If you want to be a good network engineer, you should know this small definition, this small theory. It's like we want to become a medical doctor. So we have 6 years. We study 6 years. Year 1, we still have 5 more years. So we still have 5 more months to study. So all these small things should be known. So the MAC address for a broadcast, if a destination MAC address has FFF, all FF, it's a broadcast MAC address, a broadcast message. So CCNA1 is introduction to network, a lot of definition theory. Then when we finish and we go to CCNA2, it's where we're going to do a lot of configurations. So for now, Cisco says, okay, you are new, you're starting your career in IT. Let us give us the foundation of IT, anything related to networking. That's why you see a lot of A lot of stuff like that. Okay, MAC address table, you know now. I did explain. See, if you have a switch per port, it's going to record the MAC address of that PC that is connected to that port. You see port 1000A, you see, it's the MAC address of that PC. So if PCA want to communicate with PC4, PCD, you see source MAC address 000A, destination 00D. You see 00. So if you want to communicate, when the packet will arrive, you say MAC address 00D, what is it? This is 00D, is connected to port 4. Okay, so go to port 4, then you'll reach your destination. So when you send your message at the switch, it's going to check where do you want to go, destination MAC address. You check on the MAC address table, you say, I know you, go to that port. If I don't know you, which is something very important, if a switch doesn't know where to forward a packet or a frame, he will send to all the ports of that switch except to where it comes from. So if PC,
Mr.
yes,
Max,
yes, question?
Gauthier,
Yeah, Gauthier? Mhm.
I want to know MAC address sometimes doing the same way like router in the internet.
Sorry, can you please repeat again your question?
I said that the work that MAC address is doing is the
Mhm.
same work the router is doing also.
Exactly. Very good question. So here the switch will deal with MAC addresses, but the switch will deal with a routing table, networks, a network table. Yeah, network table. So that if your message arrives at the router, where do you want to go? You're going to check on the table. You want to go to that network, go that side. It's exactly the same thing. Thank you for your question. Mhm.
Thank you.
Yeah, so you have a video, they do that demo I did with the packet tracer. Mm. Another video again, watch it many times. View with switch MAC address table, I did a demo already. Forward methods, I did explain, store in forward and cut through. Store in forward, you have a lot of explanation, cut through, I did explain already. Anything else, full duplex, half duplex. So check this one, check this too, very important. So all these things that I give you when I'm training you are the most important, that it's compulsory for you to know. Now, when you go back to your NetAcad, you'll get extra info. But the main thing is what I'm teaching you. NetAcad, they add more explanation, more. So if you have a switch, here is set up for duplex, half duplex, but we don't have half duplex anymore. We should remove this slide. Everything now is full duplex, so there is no problem. If you don't know which type of cable you should use, you can configure that feature on the switch called Auto MDix. Then it will adjust the correct cable for you. But you as a network engineer, make sure you use the correct cables. So read on top here, and we can continue. Okay, all these things, if you see the pattern, you copy paste on a Microsoft Word document, you make your own summary, neat, nice. So that's all for chapter 6 and 7. It's about the switch. So if really as a student, you know to do this topology, you know the different type of switches, manage and unmanaged. You know what is MAC address table, how to find it, what is it. You know the difference between full duplex, half duplex, forwarding methods. That's all. That's all. At CCNA2, now we're going to configure security, how to secure the switch. Any questions? Yes.
Mr. Max, mm, can you just clarify what is the difference between internet and internet?
The difference between?
The difference between internet and Ethernet.
I don't know what you're saying. So Ethernet.
Okay, I said that.
Uh-huh. So I know internet, yes.
Let me spell it. Internet and or ETHARNET. Internet.
Okay, so you say this on internet, and then?
Yeah. Ethernet and Ethernet.
Like that.
Exactly.
Okay, no, this one is the technology for network for network cable. That one. Network cable technology. Technology. Your normal network cables. How are we going to build them? Are we going to set up STP, UTP? Are you going to do so? All these technologies around a normal network cable is called Ethernet. You see. Now the internet is what? Interconnection of all LANs plus ones. You see.
All right.
Yeah, it's a good question. Yeah, it's a good question.
So in this course, are we gonna learn CCNA 1, 2, 3
Yeah,
until on October?
yeah. That's why it's 6 months. It's deep. That's why it's expensive. This course is expensive. Huh? You can go to CPU today, it's 50. That's why it's expensive, because it's a lot of information. It's like you're doing a bachelor degree. It's a lot of information. And when you finish, you're ready to work because you know the technologies, you know your packet tracer. If you know your packet tracer, you'll exactly. So from time to time, we'll be meeting at Scalabrini. I'll bring the equipment and you'll do your connections, you'll do ABCD. Huh? So so if you go to our network, to our Learn Networking Academy, Learn Networking Academy, to my to our website, you go to gallery. Coco and his wife, I put your picture here so that people will see you. So yeah, from time to time we'll be at Scalabrini, where I can bring equipment that you can see. I'll show you. Okay, people who did the IT essentials, I think you did this one already. And when it comes to, yeah, you see the router. I'll bring the router, we'll do some configs, I'll bring a switch, and you're going to do everything we do theory first. If you're good in theory, now we go to packet tracer. When you're good in packet tracer, now we're going to do. But if you don't know packet tracer, you don't study your stuff, forget about this one. It's like you want to drive a car. You don't go to a driving with driving school, and you want to take a car to go to the highway. You want to die. You see, so we need step by step. So yeah, so we'll bring all this equipment, and I'll do some demo. So if you go in a company, I'll show you something. I'll show you what is that thing? Where is that thing? It should be okay. These are some other stuff. So our graduation is in December. Please register on the form for me to know how many people are coming, to select the correct venue, catering, and hiring all of these gowns stuff. So if you go in a company, you'll see that big equipment is called a cabinet. And inside you put all your routers and your switches. So if you work in a company, any cable is linked to a PC. So yeah, this is how it is. You have your switches, you have your router. If you know your packet tracer, it's exactly the same thing, nothing else. Nothing else. But I did add other pictures. I forgot to put them here. I forgot to add other pictures. No, I forgot. Okay, I'm going to add them here. So this is it. Any other questions? So now that we did general information about networking, what is networking? We did a bit of basic switch and end device configuration. We did the physical layer. We did the data link layer with all this Ethernet stuff, switching. Now, next week, we'll start the router. What is a router? Layer 3. So we see step by step. We know the cabling at the physical layer. We know now the switch with MAC address table. Now we're going to study the router with IP addresses. It's what we'll be doing with IPv4, IPv6. When we are done, we'll do the transport layer, application layer, and we are done. So everything is well organized. And,
Router also is in data link layer.
no, Gautier, how can you say such thing? Okay, check here. Which layer for the router?
Yeah.
Network
Gautier.
layer.
Network layer.
Yeah. Network. Yes, network.
Yeah. So please don't make that mistake at a job interview.
Yeah.
Yeah, please. So that's all, guys. Make your own notes, your own summary the way I do. It's clear, so that you have. Also, if you go in your NetAcad, what is that NetAcad of mine? You go in your NetAcad. There is introduction and the summary. So check them also. So I'll send you something to be done for the weekend, an assignment. The other class, we have it already. You too, you must do it. So if you go switching routing, introduction to networks here. Okay, if you come here and you open, for example, chapter 6, you have why should I take this module? Very important. And you also do your quiz, and at the end, you'll have a nice summary. Why this layer? What? So always, it's well summarized, and you practice many times with the quiz to make sure that you understand. See. Also, guys, now you can do 2 exams. I'm going to post again. After chapter 1, 2, 3, you have a checkpoint exam. Please do it. It's for grades. After chapter 4, 5, 6, 7 that we did, you have another exam. Please do them. Any other questions before we end the session for today? Okay, no questions. I wish you all the best. Have a good long weekend, because Monday 28th is public holiday. We'll be meeting Tuesday 29th online again. When I get the feedback from Scalabrini, I'll let you know. We are very busy, a lot of trainings, a lot of workshops. So that's why I managed to book, but what I did is for July. So for now, we use a bit of there is a lady, Priscilla. So the only booking I made for now is the 5th and 9th in July. Sea Point Civic Center. She sent me the documentation to. Yeah, it's Sea Point Main Road. Yeah. And so I need to make payment, not payment, but I need to fill all this documentation. What is it? The booking form and pay the deposit. So this one we'll talk about it later. Okay, so if no other questions, then thank you for today. Please study minimum 2 hours per day. And yeah, at a later stage, we'll do some labs. Some labs.
Max,
Yes.
please, can you send us the record, please?
We record. Let me check. Are we recording? Yes or no? I forgot. No, it's
Yes,
yeah.
you did.
With
You
us
did.
for recording.
Yeah. So I'm ending the recording so that it will start.